Welcome to this final lecture in the series on bug advocacy. My focus today is on your writing, the basics. Your reports go into a bug tracking system. What those reports look like is driven by your corporate culture. Some organizations get by just fine by reporting each bug on a single 3x5-inch note card. Most use, or should use, a more elaborate database. You can imagine how different the reports are in these two different formats. Companies also differ in who they allow to access the bug database, who gets to write, read, modify, and close reports, and how much statistical data and what kind of data comes out of the system. Ultimately, the set of policies for bug tracking either serve the mission of the system or they don't. In my experience, too few companies explicitly consider the mission of their bug tracking system, and so they make suboptimal policy decisions that seem fine on their own, but that conflict with achieving the system's primary task. Here's some of the many uses commonly made of bug tracking system data. If any of these is fundamentally important to you, if it's a must-have from the tracking system, you should recognize it explicitly in your statement of the system's mission, because it's going to impact how bugs get reported. Let's consider an example. Some companies really want to tie every bug report to a specification. They all want to be able to say, this is a bug because of a nonconformity with this part of the spec. The code associated with implementing this part of the spec was much buggier than that part of the spec. And they also want to tie the individual test cases back in a test case management system to individual pieces of the spec. This might be useful, but I want you to consider a few questions. First, how much work does this add to the bug reporting process? Is it worth it? Second, does this encourage people to stick with specification-focused testing? What about bugs in areas that aren't well specified? Third, does this encourage people to stick to old test cases? But what about exploratory tests? What about bugs found by non-testers? Those bugs don't show up in the test cases. How do you manage more creative tests that combine many features and therefore cross many parts of the spec? How, especially, do you cope with an adaptive automated test strategy where the automation software keeps changing the tests to search for bugs more effectively? So the advantages of traceability might outweigh the costs. If your goal is narrowly focused specification-driven testing, then a system that ties everything back to the spec and everything back to a test case management system serves that. But for other companies, bug reporting requirements like these might change how the typical tester tests in ways not intended. When people said, gosh, it'd be nice to get this information out of the system. Be careful what you demand of the system, because it makes demands back. Now, a mission statement is typically one sentence long, not many words, tightly focused, that emphasizes the reason for your activity. The bug tracking system is such a fundamental tool for a development organization, not just the test organization, that if you haven't agreed on a clear mission, you should carefully consider investing the time working with the rest of the development organization to write a mission statement and then conform your system to that statement. A common mistake in mission statements is to include too many things. Those look pretty on paper, but you can't avoid the hard decisions. You either make them in the making of the mission, or you argue about them and their consequences later. I have a preferred mission for a bug tracking system. It doesn't work in all contexts, but I'll use it here as an illustration of a mission and pretend that this is the mission for bug tracking. If your company's mission is different, some of your conclusions later about what's appropriate and what's not will be different from mine. My preferred mission is this. The bug tracking system exists to help us get the right bugs fixed. Anything we impose on the tracking system that reduces the probability that the bugs that need fixing will be hunted, found, reported, and fixed is incompatible with this mission. And that usually means we shouldn't do it. Let's look at another example on this list. Suppose we start tracking the number of bugs reported by the tester, or the number made by the programmer, or how long on average it takes the programmer to fix the bug. These are all human performance metrics. Bob Austin's book, Measuring and Managing Performance in Organizations, provides a lot of insight into the complexity of using human performance metrics. When you start counting how many bugs a programmer makes, she's going to want this count to be low. The system gives her an incentive to pressure testers to report fewer bugs, to argue that bugs are not bugs, to argue that they are duplicates of other bugs, to argue that the tester is just reporting some things to inflate his bug count. And no one with any integrity would waste our time on these reports. What do you think all this does to the decision-making process for handling bugs? When I talked about hard to reproduce bugs, I said that it's a good practice to report each failure so the debugging programmer has many descriptions that give many different details. But think about being the programmer who made one bug and gets dinged for 20 reports. How long will it be before duplicate reports of hard to reproduce bugs get banned from your system? By the way, some people say that bug metrics are bad if you measure individual performance, but they're entirely okay if you combine them into group statistics, because then you see trends but no one feels singled out. That's a very nice wishful thought. But if I'm the test manager or the project manager, the statistics of my group single me out. And as a manager, I probably have more power to create a bigger mess. Now, I'm not saying that bug metrics are inherently bad. Well, sometimes I do say that, but that's not my point today. Today, what I'm trying to say is that deciding to compute bug metrics carries costs, such as management costs. It has effects. If your mission is getting the right bugs fixed, bug metrics will probably distract you badly from that mission. But on the other hand, if the primary mission of the reporting system is personnel management, and this is more important than supporting the bug fixing decision-making process, then bug metrics fit right in. A company has every right to set up personal evaluation systems that are based on the details of their staff's work. This helps the company make better decisions about raises, promotions, layoffs. I don't see anything unethical about using a bug tracking system this way, as long as everyone knows that's what's being done. But the point that I want to emphasize is that this is a different mission. The personnel management system that helps you evaluate the effectiveness of your people based on their bug reports might become a much weaker tool for quality control of the bug finding and bug reporting process compared to most other bug tracking systems. But that might be okay. You just have to choose the mission for your system if you're going to optimize your work in ways that will help you get that mission accomplished. From here, let's assume that the mission of the tracking system is to help you get the right bugs fixed. This slide lists some characteristics of this system that I think are critical. One of the critical issues in these systems is that it has to deal with controversial reports. After all, quality is valued as some person, and there are a lot of some persons on your project, and they have different priorities and different needs, so they're going to evaluate bugs differently. A good tracking process has to insist that the reports are well enough written for the affected stakeholders to understand why they should care, and for the people who will have to make the requested changes to estimate the costs. It has to foster a level of discourse that leads to good decisions. Putting into the terms we used last lecture, a good tracking process should encourage people to take the time to build their credibility when they report or comment on bugs. And of course, it should make sure that no bug gets lost or hidden until it's too late to do anything else but accept it. Within this mission, writing an excellent bug report involves several types of thinking. So I'm going to present these in an order. First do this, then do that. But in practice, these are parallel activities. They all have to be done, and the ideas for them hit you when they hit you. The first one that I'll mention is the idea of isolating the bug. Many tests include many more steps and adjustment of more variables than you actually need to replicate the failure when you find it. The best written bug report is the one that reaches the failure in the shortest, simplest set of steps. So you can strengthen a bug report by repeating the test while skipping some of the steps. If you can take out the steps that aren't needed for the program to fail, you can make the report stronger, more compelling. That's easier said than done. Some tests involve long sequence failures or large sets of data. If your test is complex, it can be very challenging to figure out an efficient order for swapping steps in and out. I find it useful to look for early symptoms, minor misbehaviors that lead up to the big failure. The next few slides list examples of symptoms. One of my heuristics is that in a complex test, anything that causes a symptom is probably a critical step for the failure. So when I see a symptom, I treat that as the bug for a while. I look for the simplest set of steps to get to the symptom. So in a test that involves 100 steps, if it showed its first symptom after the 25th step, I focus on these first 25 steps. Maybe I can boil these down to the 5 steps it takes to get to the symptom. Then I repeat the test with just these 5 plus the next 75. If it works, I've simplified the first segment of the test by 80%. That's a good start. Sometimes I have an intuition that I've found all the critical steps. At that point, I'm going to take out everything else that I can from a complex bug, and I'm going to see if I can replicate with just these few steps that I think are all I need. If they aren't really all that I need, I add back just a few. If I'm right, this is a lot faster than the much more systematic reduction of the test by removing small pieces and seeing whether we can still reproduce it. Your intuition will get better over time. Give it a chance to prove its worth. The final aspect of bug isolation that I want to note is a policy that I always follow, which is to limit reports to one bug each. Programmers and project managers often encourage testers to report related bugs in one report. This is especially true in companies that have been cursed with bug count bureaucrats. We wouldn't want to inflate those bug counts. You are reporting two different failures if you can imagine the programmer fixing one and leaving the other unfixed. Combining these makes a longer report that is harder to understand. Your grouping it will also have flaws. You don't see the underlying error, so you can't know whether two failures actually stem from the same mistake or not. Rather than putting multiple bugs on one report, I don't do that unless I'm positive that the underlying coding error is the same. But other people prefer to manage fewer reports. Again, especially true in companies that emphasize managing by the bug count numbers. If the project manager does classify several bugs as duplicates, make sure that the report that remains open cross-references all these closed ones. And when the open bug comes to you as fixed, retest the alleged duplicates along with the one open bug. Another thing that's often useful to do with the about-to-be closed bugs is to copy the information from all of the alleged duplicates into the description of the one bug that was left open. To the extent that the reports are not redundant, this collects the relevant information and puts it in one place. So when we find a bug, we simplify it by isolating it. Then we maximize it. That is, we look for more serious versions of the bug so that we can make a more compelling report. We looked at this in a lot of detail in the second lecture. There's no point in repeating it here. We also looked at generalizing bugs in the second lecture. The broader the set of conditions under which this failure occurs, or the more likely it is that people will reach this bug, the more serious it will be perceived and the more likely it will be fixed. I talked about the idea of externalizing a bug mainly in the first and fourth lectures. Bugs are bugs because someone cares about them. Bugs reduce the value of the product for a stakeholder with influence. You make the bug compelling by making people understand what value has been lost. And you might do that by referring to other things outside of the product that tell you what the costs of this problem are going to be. This is a very hard problem for outsourced test labs. I had a long talk with a colleague who I respect highly, who works in an Indian test lab testing American and European software. His staff are so separated from the key stakeholders in the United States or Europe that they don't even entertain the idea that the testing team should do or could do this kind of analysis. There's no magically right solution to this. Sometimes it is best to expand the scope of the external testing effort, teaching them how to assess the external problems that are caused by the product's design, for example. Other times, it's much more effective to investigate the design issues in-house. It's risky to trust an external test group to do this work when they don't fully understand the product and its market. A company builds expertise in its own products over time. A company that develops software for its own use builds expertise in understanding its own needs and its own processes, its own business over time. An outsider doesn't automatically know this, even if they've worked on products in this general category before. In my experience, companies will often outsource testing without realizing what their own staff have been providing. Therefore, they don't build into the process the time and budget and staffing for the follow-up investigation of the impact of the bug. But that's what an in-house tester who understands the product would naturally do, as would a trusted service provider who knows the company and its products really well. In these cases, the lack of investigation is invisible to management, but an important part of the quality control of the product is really being lost. I worked with a project manager once who was really proud of his ability to ship products on time. I'm going to call him George. That's not his real name. I used to take George out to the bar, and over drinks he'd brag about his favorite rule: it's not a bug unless a tester reports it, and how he dealt with project pests, testers who wanted to report too many bugs. If George could get a skilled tester annoyed enough with him personally that tester would eventually show that annoyance in meetings and in comments on bug reports. And George could then use this, drawing management attention to the personality conflict, especially if the tester's comments could be interpreted as directed at some programmers rather than only at George. Oh, these poor programmers. Getting beaten up like this, it affects their productivity. Well, there's a predictable result. Managers come in to try to manage the personality conflict. And so anytime the tester would write anything, some other tester had to review it. This kills the tester's productivity. It kills the reviewing tester's productivity too. If they're both assigned to the same project, you lose 2 for 1. Remember George's rule. It's not a bug unless the tester reports it. And if the program doesn't have any outstanding bugs, you can ship it. Until I started working with George, I'd never realized that some people did this kind of thing deliberately. But even people who don't do it deliberately can trigger credibility-destroying responses from testers. Let me suggest a heuristic. If you insult someone, if you show anger, if you use harsh language, if you let them get to you, you might or might not win the particular fight that you're in right now. But the price will be credibility, trust, and goodwill. The next few slides list typical fields that you'll find in a bug report form. One of your tasks in the BBST course is to report some bugs, so familiarity with the typical fields is a necessity. The specific fields and their names vary from bug tracking system to system. This is a generic list. I want to get across the common ideas independent of any particular implementation. The software testing process documentation for your particular project will probably describe that project's bug tracking system in much more detail. The most important field in a bug report is its summary. Most people who interact with this bug will read only the summary, or they'll remember only the summary. The bug tracking system probably prints long lists of open or deferred bugs. Managers and triage team members look at that report. The list probably shows summaries of every bug, and it probably doesn't show any of the details. So what you convey in the summary is what they see, and probably all of what they see. You have about 70 or 80 characters, 10 to 15 words to summarize the bug. Start by describing the failure. Be specific. Words like failed or problem are not specific. The program wouldn't be in the database if there wasn't a problem, if it didn't fail. A more specific description might say the program lost data. It displayed the wrong result. It calculated the wrong answer. After you say what the failure is, say a bit about when it happened. If the failure happens only under a narrow range of conditions, it's important to indicate that limitation in the summary. For example, suppose the program will crash when searching for a specific type of data, but only on some systems. At this point, you might not know exactly what systems are involved. But you do know enough to say, as the last 2 words of the summary, configuration dependent. Anything you do that is seen as raising unnecessary alarms or exaggerating the severity or generality of a bug will hurt your credibility. Putting some constraints into the summary has the reverse effect. It improves your credibility. People come to trust you. The next field that some companies use heavily is report type. What kind of problem are you reporting? I've seen many different choices in report type fields. The value of this field is that it avoids misunderstandings. For example, suppose that you're arguing that the design of program is unusable, and the programmer responds that the program works as designed. Well, you and the programmer can both be right. If you flag the bug as a design issue, though, then it's easy to send the report back to the project manager and politely say, I agree, the program does work as designed. Please assign this to the designer, not the programmer. Some companies use enhancement as a choice for report type. This lets the tester say, I think the product could be improved, but I understand that this improvement might not be within the scope of this release. Programmers might also say that. This is an improvement that's not within the scope of the release. And that's appropriate if you're doing contract-based development with a thorough specification. The idea of an enhancement in that case is that it requests something that's outside of the contract. But in development for in-house use or for sale to the mass market where there is no contract, the specification is nowhere near as detailed. And when the project manager assigns a report type or a resolution of enhancement, what she really means is, we don't feel like doing this now, so we're going to tell you that you don't understand the scope of the project. The last 2 fields that I'll note on this slide are severity and priority. Testers can often assess the severity of a bug, but testers aren't the only people who have an opinion about severity. On some projects, there's a lot of disagreement, and the very best way to manage disagreement is to let everybody have their say. That might mean having multiple severity fields. One for the help desk to say this is what it means to us, one for the testers, maybe one for somebody else. In contrast, priority is the project manager's tool for scheduling the fix. I don't think that testers should ever enter a value into this field. The next field I'm going to focus on is problem description. It's very important for a problem report to be self-contained, easy to read, and very well organized. Think about the person who's reading the bug. Many bugs are fixed late in the project by people who are working very heavy overtime. These programmers are overtired. They are less able to think clearly, less able to remember things as when they're well rested. They're also probably more easily annoyed, very quick to give up on finding something out, very unwilling to look in 2 or 3 places to get a full set of information. These are the people you're dealing with, so write your reports for them. So I start the problem description with a brief restatement of the problem. And then I follow that up with a step-by-step description of the problem. To keep that description simple, number every step. Every few steps, tell the person what they should be seeing at this point, so that if they make a mistake following your instructions step by step, this lets them see that pretty quickly. Write your instructions so that someone who is not an expert with the software can follow them. Use short sentences. Make it easy to read. At the end of the list, describe the failure. Do this and this and this and this, and see that. That's the failure. If it's not obvious that this is a failure, say what you expected and why you expected it. You don't have to say that you didn't expect the program to crash. Obvious failures don't need explanation. But suppose the program does a calculation and displays 73, and that's wrong. 62 is the right answer. So in your report, say that. Say that you expected 62, and maybe explain why. You start the report with the simplest path to the failure. But after that, describe any challenges that you think the person who's trying to reproduce the bug might have. If the bug's configuration dependent, or if there are configuration details that might be relevant, list them in the report. You start your report with the simplest way to get to the nastiest failure. You probably came to that by doing some follow-up testing that started with a longer way to get to a less nasty failure. You need to report that one too. It makes the programmer's troubleshooting work much more efficient if they see variations that lead to different results. Helps them spot the problem. It also protects your credibility. You're giving the full story, not just the most sensational story. I make this point about credibility because I've met testers who intentionally don't report conditions under which the failure is much less severe. They do this because they're afraid of giving the project manager an excuse to defer the bug. But the result is that the project manager starts mistrusting all of their reports, and then does deferrals that are simply less well informed. Another interesting field in many databases is the suggested fix field. If you don't have something particularly useful to say, don't say anything in this field. It adds very little value, and it can often make you look naive or foolish because you'll suggest things that are unrealistic. And there are exceptions. If you criticize the design, you can say what's wrong with the current design in the problem field, and if you have a good alternative, you can describe that in the suggested fix field. We talked about bug status in the discussion of reproducible fields. That's where I defined the holding state, dumpster. So let's move on to the resolution field. Resolution codes vary from company to company, but the concepts are pretty much the same. Either the bug gets fixed, or there's a reason for not fixing it. But sometimes project managers class a bug as not a bug, and sometimes testers class a bug as not a bug. They shouldn't have reported it, and so they withdraw it. Only the tester who reported a bug can withdraw it. In the ideal case, this pulls the bug out of all of the tracking statistics. Now, the final resolution on the page, in WATSTA, comes from the project manager. It's a response to the bug that gets reported or reopened in release after release after release. The project manager is saying this bug should be treated as a permanent part of the design of the product, and therefore further discussion, now or in the future, is a waste of time. Comments fields come up in most modern bug tracking systems. They allow arbitrarily long discussion of a bug by arbitrarily many people. You can surface disagreements here. You can discuss reproducibility here. And this is where you often capture information about the impact on some stakeholder that you didn't realize would be impacted. Several bug tracking systems include fields that I try never to use. Let me state my principle for bug report fields. If I can't manage the accuracy of a type of data, I don't want to be responsible for that data. Simple example, the test group can't fill out who fixed the bug because we don't know. If the company wants to keep that information, the person who fixed the bug or that person's manager has to enter this into the bug report. In my experience, programmers, project managers, and other non-testers aren't very interested in the administrative or archival data in bug reports. So nagging them to enter data into a field they don't care about is a losing effort. I won't do it. Project phase is my next example. I see study after study that talks about what phase a bug was created in and what phase a bug was fixed in. Well, the first problem with this is that the phase classification itself is usually baloney. On many projects, requirements analysis, design, development, and testing are parallel activities, or they're done together in many short iterations. So what does it mean to say that a bug was created in the design phase if there is no explicit design phase, or if much of the design actually happened after the formal end of the official design phase? The second problem is that the test group has no way of knowing when a bug was introduced into the project. Who's responsible for filling out this field? What efforts are they willing to invest to make sure that what they enter is accurate? In my limited personal experience, almost every time that I've looked at a report that tells me what phase a bug was created and what phase a bug was fixed, when I look behind that, I find no empirical foundation for that report. The rules for assigning phases are way too vague. They're applied too unreliably for anyone to base any decision on the result. It's my experience. Many other people, I'm sure, have seen something that I've never seen. But without strong quality control on this field, and not by the testers, by the people who have the information about the phases, without strong quality control, I think this has no business in the bug tracking system. Another cluster of bad information that I see in some bug reports calls for estimates of the cost of repair, the programmer time required to troubleshoot and fix the bug, the scope and risk of the fix, the root cause of the bug. Maybe the debugging programmers have some of this information, but the testers have none of it. If the debugging programmers want to track this information, great. But if they won't own these fields don't belong in the database. I've met test managers who argue that this information is very important. It must be in the database. Well, I agree this information can be useful if it's accurately recorded. But if the people who are the source of the information won't gladly and reliably and accurately provide it, there is no hope for this data. We have enough battles to fight without tilting at these windmills too. Next windmill. How much money did we save by fixing this bug? I don't know how to estimate that. Someone might know how to estimate that, but that someone probably doesn't work in the test group. If that someone is willing to voluntarily fill in this information, great. If not, we don't know it, so we can't write it. And finally, there are the employee performance fields. Who should we blame for this bug? How lazy is the programmer who fixed it? If the mission of the bug tracking system is to get the right bugs fixed, fields like this are fundamentally in conflict with that mission because they breed mistrust and fear without contributing one little bit to the accuracy or wisdom of bug fix decisions. Well, that brings us to the end of this series. The next 2 slides provide my top 7 list of lessons that I've tried to get across in this lecture series. If there is one overriding lesson, it is that we are advocates for bugs, not neutral reporters. Our advocacy is designed to help stakeholders who are affected by the bugs make their wisest decisions, make best decisions they can about what should be fixed and what should be left alone.